Good day, students. In this video, we are going to talk about something called a box and whisker plot, or I might shorthand say it box plot. So what we are going to do is take what we have learned about quartiles, about mean, median, mode, and range, and we are going to start putting them into graphs that display the data. So in this video, we're going to talk about this one specific type of data graph because it is a little bit more complex. It's not like other graphs. And then in the next few videos, you'll see some types of graphs that I'm sure you're familiar with, such as your dot plots, your pie charts, your Venn diagrams. But this video is going to be dedicated purely to box and whisker. So I am going to let you take a couple of moments to pause the video and copy what you see on the screen. So if you want to take a moment to pause and copy down what you see. Okay, and I couldn't get the whole page in the video, so here is kind of what the bottom half of your page is going to look like. We're going to talk about the steps to create, and we're going to create some box plots. So go ahead and pause and copy down the steps to create so you don't have to frantically write them later. All right, so let's go back up to the top and let's talk about what is actually needed to create a box and whisker plot. So a box and whisker plot from the start shows how the data is distributed in the values. So we're going to talk about, is most of the data kind of leaning towards the upper half, the lower half? Is it pretty well evenly distributed? What's going on? So in order to create a box plot, there's 5 values that we need. So the first are just the highest and the lowest value. So we need the highest value in the set and the lowest value in the set. So that's just what's the biggest and the smallest number in the set or the list of numbers. The next 2 things we need are our quartiles. So we need our quartile 1 and our quartile 3. And then the last thing we need is the median, which is also another quartile. It's our Q2. So we need all 3 of our quartiles, 1, 2, and 3, at the highest value and the lowest value in the data set to create a box and whisker plot. So here are the steps to create. I'm going to kind of walk through them very briefly, and then we'll actually go through and do that on a number line. So the first thing is we need to calculate the 5 values that are needed. So typically what's going to happen is we're going to get a list of numbers. We're going to have to put them in ascending order, and then we're going to have to find these 5 things. Once we do that, we're going to draw a number line and plot points and plot the 5 values above the numbers. So the number line can be labeled, with our lowest value and our highest value, and then we can kind of number it by 1 in between. We could also number the number line in different intervals. We could count by 2s, we could count by 3s. If there's like a lot of numbers in the data set, that's also totally allowed. The next thing we're going to do is we are going to create the box of the box plot. So we're going to draw vertical lines through all of the quartiles and connect those to make a box. And then we're going to draw the whiskers of the box and whisker plot from the box to the highest and the lowest values. So let me kind of show you what that looks like. So I kind of drew a number line here that has the numbers 2 through 10 on it. And let's say that 2 and 10 are the highest and the lowest values in the set. So I'm going to plot a dot above the number line, not on the number line. It's really important that in box plots we're plotting above it, not on it. Kind of like a dot plot in a way. So my highest and lowest values are plotted. And then let's say my first quartile is 5. My third quartile, let's say, is 8. And then let's say my second quartile or my median is 6. So you'll notice I have all 5 values plotted on the number line above the number. So to create the box, I'm just going to draw kind of a short vertical line through all of my quartiles. So my first, my second, and my third. And then I'm going to connect kind of the top part of the line and the bottom part of the lines and create a box. So you'll notice that the edge of the box here is our first quartile. So I'm just going to label that Q1. This right here is our second quartile, so Q2, and this right here is where our third quartile is located. So I have my median in the box, and you'll notice that the median does not split the box in half. That's perfectly fine. We'll talk about what all that means in a second. And then to draw the whiskers, I'm going to just basically draw from the point of the third quartile to the highest value, and from the first quartile point to the lowest value, I've now created two, quote unquote, whiskers to my box. So this is what a box plot looks like. It's not exactly super exciting, but it does kind of show us some information about data. So when we talked about calculating quartiles, we talked about something called the interquartile range. So on a box plot, we can visually see the interquartile range, the difference between the third and the first quartile, is also the length of this box. So the IQR on a box plot is just the length of the box. Okay, the interquartile range also shows 50% of the data. Okay, because it is between the third and first quartile, so anything below the first quartile, that's like the first section. Anything above the third quartile is our fourth section. The other two sections of the data between Q1 and Q2 and Q2 and Q3, that's where half of our data lies. So this is showing the range of 50% of our data. So 50% of our data, if we're just looking at the numbers in this particular graph, lie between the numbers 8 and 5. The rest fall into the other categories. So that's something that's kind of unique about using a box plot and actually using the interquartile range that we talked about before. This data that is on this box plot, this is called normal distribution. So what that means is the data is distributed pretty normally. So most of the data either like it kind of falls in the center and then goes out to the edge. We also have data that's skewed. So I drew two other number lines. I'm not going to label them with numbers, but I'm going to kind of show you what data that's skewed looks like. So let's say like we have a box plot that's kind of labeled like this. And we have kind of a short whisker and then a really long whisker on one side. And what if it's like the opposite? So like if I drew a box kind of towards the right side and had a short whisker over here, and let's say my median's just right there, and then I had a long whisker on this side, you'll see that the data is not really like center on our values. So when it's kind of pushed to one side or the other, it's called skewed, S-K-E-W-E-D. And the way we describe each one is based on what side the data is pushing away from. So this is probably like the most confusing part of this whole lesson. So even though the data is over here on the left-hand side, right? Like this is where the median, all the quartiles, everything is. We actually describe this particular graph as being skewed to the right, even though all the data is on the left-hand side, because it's skewed away from the right-hand side. So it's kind of the opposite of the direction. So this is going to be skewed left, even though the data is on the right-hand side, because all the data is skewed away from the left. So if you need to write yourself a note, opposite than drawing, that's kind of a note you can leave to yourself to remember, like, okay, skewed right means actually all the data is on the left. Skewed left means all the data is on the right because it's skewed away. You can write the word away from that side. So it's skewed to the right because it's away from the right-hand side. So this is how we create a box plot. This is how we determine how the data is distributed on a box plot. So skewed data means that most of the data in this case, so most of the data is going to kind of fall to like the upper half. So the majority of the numbers were actually like larger than the median. But there were some values that were below the median, which is kind of why it's skewed. Normal distribution means there's about the same amount or type of data in the upper and the lower half. Skewed right means the opposite of skewed left. All the data is towards the lower half. So what we're going to do for practice is you're going to practice reading and making some interpretations from a box plot. I'm also going to ask you to create some box plots, which all you need are the 5 steps that we did before. So for your practice, I'm going to have you create a box plot using the values. And then I'm going to ask you to describe the data. So you're going to create a box plot using the following set. So remember, you need to get your 5 values and then use the steps that we talked about on the other page for how to create. And then I want you to describe how the data is distributed. Is it have a normal distribution? Is it skewed to the right? Is it skewed to the left? If it's not perfectly, if it doesn't look like it's a perfect normal distribution, you can say like, oh, it's slightly skewed to the right or it's slightly skewed to the left. You can say that as well. So if you have questions about how to create a box plot, how to get one of the 5 values that you need, or how to read a box plot, please make sure you go back and watch this video for a second time. I would also encourage you to reach out to your teacher if you have any additional questions. And as always, I hope you guys have a wonderful day and see you soon. Goodbye.